All right, welcome to another exercise on the topic of moment. Force F of magnitude 30 newtons is applied perpendicular to a bent bar depicted in the figure. Determine the moments of F about point A and point B. So basically, when we are asked to find the moment about a point, first thing is to find the distance from the given point perpendicular to the line or lines of action. First of all, I'm going to find the moment about point B. There is only one force vector, which is 30 newtons, and it has the vertical distance of 1.6 meters from the required point B. So since it's vertical, I'm not going to find the force vector components in this scenario. So easily I can find the moment about point B, which is F times the distance BC. So F is 30 newtons times 1.6, which will be 48 Newton meter. So this is the moment of force F about point B. Because as you see, when I draw a line from point B toward the line of action, it's perpendicular to the line of action. So this is exactly the distance 1.6 given on the figure. But when it comes to point A, the scenario is totally different. So in this case, I have to find the force vector components. So the force components of F will be Fx and Fy with respect to horizontal and vertical directions respectively. The angle here is 45. So from geometry, when two lines are parallel, any diagonal or diagonals parallel to each other make the same angles on the initial parallel lines. So since the joint point of this bent bar creates the angle of 45 with respect to the horizontal direction, force F makes the same angle of 45 degrees with respect to the horizontal direction. So Fx will be F cosine of 45 and Fy is f sine of 45. Now to find the vertical distance between these two force vector components and point A, I have to find these two distances, which I call one of them H and one of them W. This bent bar is composed of two portions, the bent portion and the vertical portion. The vertical portion, the measurement is noun, which is 1.6 meters. I know the dimension of the bent part, but that dimension doesn't work in the case of the moment about point A, because I have to find H and W. Again, from geometry and trigonometry, I can say, since this angle at the joint is 45 with respect to the horizontal direction, so if I consider a dashed line perpendicular to the point B, this angle will be 45 as well. So this is H because it has the same dimension, and I can say H is nothing but the sine of 45, because here I have one right triangle where this is 45, this is H, and this is the hypotenuse, which is 1.6. So basically, H will be 1.6 times sine of 45. W will be 1.6 cosine of 45. So I found these two dimensions. Now I can easily find the distance between the point A and the lines of actions of two force vector components. Now, the moment about point A will be Fx times the distance, the vertical distance, which is H plus 1.6, and H is noun, which is 1.6 times sine of 45 plus another 1.6, which is the dimension of this portion of the bar, plus Fy times, now Fy is here. So the vertical distance between A and Fy is W. So Fy times W, which is 1.6 times cosine of 45. Now I expand this expression. Fx is f cosine 45, f is 30, times cosine of 45 times 1.6 times sine of 45 plus 1, because I simplified this expression and I performed factoring of 1.6 to simplify the bracket, plus Fy is f times sine of 45 and f is 30 times sine of 45 times 1.6 times cosine of 45. And finally, the calculation will give us the amount of 81.94 Newton meters. So this is the amount of moment of force F about point A. Just I want to draw your attention to the figure. Both of the force vector components Fy and Fx try to rotate the structure about point A clockwise. So this moment is clockwise.